Hello everybody, welcome to IB Army and I'm Jenny. Today we're going to talk about differentiation of calculus. And the first lesson we're going to learn about is the differentiating power of a function. Before we actually get started, let's talk about what is differentiation. It basically is the rate of change of something. A rate of change of function is derivative. Velocity is the rate of change of displacement, and acceleration, the rate of change of velocity. So they are all related to something else, and they're basically the decreasing power of something else. And before we actually jump into some questions, let's talk about some terminologies that could be appeared in these questions, such as differentiate, find the derived function, dy over dx or f prime x, as well as gradient function. What all of these words mean is that you have to differentiate that function. And that's what you need to do when you see these words. And let's get started. So the first rule, or the first formula we will learn today for differentiation is the decreasing power of a function. Therefore, if you have a function which is x to the power of n, when you differentiate, it will become n times n, x to the power of n minus 1. Apart from this formula, when we solve questions, we also need two other rules, such as addition rule, which is when you have several functions together, you can differentiate each term of them and add them together at the end. And the other one is constant rule, which is you have a number or a constant in your function. You don't have to differentiate that constant. You just isolate it out and differentiate that function separately. So personally, I believe the best method to study math is to actually solve problems. So we're going to start with solving some questions. And the first question here is y equals to x to the power of 3. That's the function. And you have to find dy over dx. As I said, that's basically differentiating that function. Using the formula that I gave, which is this one, please do it. And pause the video if you need to do your work. So let's see the answer. As we know about the formula, this differentiation of this function will be n times x to the power of n minus 1. So y equals to the x power of 3, and n is 3 in this case. So the derivative of this function will be 3 times x to the power of 3 minus 1, and it becomes 3 times x squared, which is obvious and easy. So now you know how to use this formula. And let's get another one. The second one is y equals 5x to the power of 3 minus 4x squared plus 2, and you have to find dy over dx of this function. Again, you see the symbol dy over dx, and it means that you have to differentiate this function. Pause the video and try it out. So how do you do it? As we said about the addition rule, some of the functions are differentiated term by term. The function is 5x cubed minus 4x squared plus 2, so we differentiate each of them using the rule of differentiating power. So each term, such as 5x cubed, will become 5 times 3, and then the power of 3 is minus by 1, so it becomes 2, so extra. So in this case, the answer is 15x squared minus ax. And also in this case, we also apply the constant rule, where you don't care or you ignore about the existence of that number, that constant, such as 5, such as 4. And especially we have to care about is sometimes people probably will be confused about the number 2, what should you do to it. But actually 2 is basically 2 times x to the power of 1, to the power of 0. And in this case, as 0 is the n, and n will times with 2, so it becomes 0. So 2 will just disappear in the function. And that's easy. So let's do the third one. Find f prime x for the function fx equals to x squared minus 2 times x to the power of negative 1. So solve this problem and tell me your answer. Again, it's the same thing. And do not be scared by the negative power. You do the same thing. In this case, n is negative 1. You just minus by minus 1 and becomes minus 2. So everything is the same. Check your answer out and confirm if you are right. The fourth one, find the derived function of f of x equals negative 2 over square root of x. Again, we see the term derived function, and it means that you have to differentiate this function. Pause the video and finish your work. So in this case, we have to express square root as a power to differentiate, or it's easier for you to understand what you do. So we can isolate the constant negative 2 out first, and the function is 1 over square root of x. And so as we know about the rules of power, 1 over a is basically a to the negative 1, and the square root can be expressed as 1 over 2. So this function could be originally interpreted as negative 2 times x to the power of negative half. And you do the same thing and check your answer. And the final question of today. So find dy over dx of fx equals to 2x plus 1 squared. Again, you have to differentiate this function. Pause the video and try it out. So as we can see, here we have a quadratic. However, it's in a bracket form. So we have to expand the bracket first. As a result, we get 4x squared plus 4x plus 1. And in this case, you can differentiate each term of those, which is quite easy. It's also possible to differentiate from the beginning, but at this point, expanding is probably much easier and probably much more efficient. So we'll expand it first and differentiate each term. And the answer is 8x plus 4, and check it out. So that's it of today, of the first lesson of differentiating power of a function. It's easy, just use the formula and don't be scared by some weird notations. They're all the same, just express it in a power. And see you next time.